Okay, let's see if we can get this last lesson for the first unit done. This is page 4, where we have the cubic and the quartic parent function. So it's going to show you how to fill out this part. Obviously, the equation for cubic is y equals x cubed. And when you graph that, you see points that are doing something like this. Even though, remember with this one, we have 3 zeros at 0, 0. And that's why it would typically get a little flat there. All right, our domain. We're asking ourselves, are there any restriction on my x's? Remember, D comes before R, just like X comes before Y, if you still get confused with that. So, are there any restrictions on my x's? No, I can put in any x I want to. In the past, y'all had probably put all real numbers. Well, this is like middle school language. High school, college language typically is in standard form, and it's going to be negative infinity to infinity. We never reach infinity, that's why we have these open brackets. So for our range, are there any restrictions on the y values? Regardless of what x I put in, my y values are going to go on forever. So it's the same thing, negative infinity to infinity. Our x-intercept crosses at 0, 0. Our y-intercept is the same thing. Maximum number of roots I can have for a third degree is going to be 3. This may be new to you in behavior. With this, the only thing we're looking at is the end of our functions. That's it. So as x approaches, as we are moving and inputting our x's going towards infinity, when I put in a -1, what do I get? -1. When I put in a -5, what do I get? -125. When I put in a -10, what do I get? -1000. So as x approaches negative infinity, our y values, our fx approaches negative infinity. So let's go the other way. As we are approaching infinity, what are our y's doing? They are also approaching infinity. And this is a continuous function. Now let's look at the quartic. Y equals x to the 4th. Even without graphing this, I know that we should have 4 roots, and we do, but it's very much flatter there than the quadratic. Ends in the same direction. Remember, that's how even functions end. So, our domain, are we restricted by any x's? No, I can put in 0, 1, 50, 500, 1,000,000. And I can do the same thing going in the negative direction. So that is negative infinity to infinity. Open bracket, soft brackets, because we don't reach infinity. Our range, our y values, are we restricted? Yes, we are, because when you look here, we are not having any y values down there. So our bottom, the very bottom of this function, is at 0. And it's a hard bracket because we reach that. We actually touch 0. But it can go all the way to infinity. Our x-intercept and our y-intercepts are the same. If this function had x to the 4th plus anything or minus anything, these are going to change. In behavior, as x approaches infinity, as it is going in this direction, what are my y's doing? They are also going towards infinity. as x approaches negative infinity. What are my y's doing? They are also approaching infinity, and it's continuous. It doesn't matter which one of these you put first, but I just want you to realize we are reading x, inputting x, and then the output is what our y is, okay? Hope that makes sense. Let's look at one more. It's very, very similar to this. The only thing is it has some turning points in there. So, looking at number 3. If you haven't already, I need you to graph that. Hopefully you have already, and you just need to check this. So, our domain for this one, let me get to that page. You should be able to fill that in very quickly. We just got through doing that. You answer that question while I put the graph up here. Okay, let's see. Now we are just going to I'm going to kind of sketch this in by what I have. It's not going to be exact. Okay, something like that. Where, when I look at these points, I found out that, well, I'll come back to this. To find these points, these, remember, are our turning points. Here, and here, and here. To get those, you have to do second, trace, find your minimum or your maximum, whatever the case may be, and then manipulate that. All right, our domain is all real numbers, so that means negative infinity to infinity. Our range, our function does not go any higher than this point right there. How did I find that? I found it by finding that was one of my maximums, and that maximum was negative 1.5 and 6.5. Your calculator may give you something a little bit different. You may have rounded a little differently, but it still needs to be in this general area. So that means that my range goes as high as 6.5, but it starts at negative infinity and it goes to 6.5, and it includes that because this is what my relative max is. There is another relative max right here. So this is negative 1.5 and 6.5. I found this max to be 1.2 and negative 1.9. and I have a relative min right here, and I found that at 0.4 and negative 2.6. Again, your numbers may vary a little bit from mine, and that's okay. As x approaches infinity, my function, my y values are approaching negative infinity. As x approaches negative infinity, whatever x I put in on this side of the origin, my y's are also decreasing, so it is negative infinity. All right, increasing intervals. Remember, you read this from x values of your turning points. What are your turning points? Right here. Okay, so that means this function is increasing all the way from negative infinity to where? Where does it stop? Does it stop increasing here? No. It goes all the way to that turning point, which is at negative 1.5. So that's where it's increasing. Then it decreases, and then look, it increases again right here, and it stops at that turning point. And then let's look at, where does it decrease? At that turning point, it doesn't stop where the line crosses the x-axis. It goes all the way to that turning point, and then from here on. So my decreasing intervals, doesn't matter how you consider this. All right, increasing from negative infinity. Where does it stop and turn? Right here at negative 1.5. Soft bracket, because we reached that, but that point is neither the highest or the lowest. It's turning. So we just need to leave a soft bracket there. Where else is this purple? Where else does it increase? Or let's just do our decreasing. So it starts decreasing at that same interval. Negative 1.5. Where does it change? It changes right here at this one, which is at 0.4. Where does it increase again? From 0.4 to what? 1.2. And then it starts decreasing where this green is at 1.2 to infinity. Now, because we have two of each of these, this is a union, because we want everything in the pink over here and right here. So it's a union of those two sets. Everything in the green, so it's a union because it's broken up by this other interval. We found these from these turning points. Where did we find the turning points? From finding the relative max and mins. So these numbers that you are going to put here come from your x values. The only numbers we have to start and end with the infinities. But the only numbers we have are here. Negative 1.5, 0.4. 1.2, that's the only ones we have, right there. All right, that's the last for our videos on the packet. Test is going to be for my distance learners on Tuesday, and that's when your packet will be due. I will send out more information on that. Thank you, bye, have a good night.